So we've sort of lost a bit of time, so I'll start. I'll try not to go too quick, but this presentation, it's really an introductory type presentation. We don't do a deep dive into all the acts. There's lots of people trying to join. Aspects of PQM as such. There's colour management's part of PQM, maintenance is part of PQM. So we're just going to sort of do a rough outline of what you could expect from a print quality management program, and any other sort of deep dive into the side things like colour management, then we can certainly facilitate that with other webinars. So why print quality management and standardisation is extremely important for printers? Well, I think it's pretty obvious why we should have standardisation and print quality management program in place, because it would increase efficiency. You can see all these points here, reduces print defects and wastes, and more importantly, like, you get more billable press time. So if the press isn't running, then the company's not making money. It's similar to flying an aeroplane. It's got to be in the sky, or the company isn't happy. Consistency and product quality, now that's extremely important for the clients. They want their products on the shelf to align, and they want all their brand colours to be consistent. Repeatability, this is something that is very prevalent in our industry, because packaging will come up. It might have like a promotion, but still the same graphic will be on that package. So it needs to be consistent with what the main brand or the hero brand is, and improve customer retention, obviously. And if word gets out how good you are and your print quality management program is working, and of course you can gain new customers. So, question for everyone on the call. I can't answer this, but how much are your print defects costing you? I don't know if anyone can answer, but if they can't answer, then maybe, if you can't answer that question, then maybe you should be looking into it, because you might be surprised how much money that you are losing. It could be just wasting time with just not having proper facilities close to the press, or the proper consumables close to the press. Training, maintenance, all this will cost you money, and because it increases defects. Maintenance and training are very imperative, I think. So this is probably a good starting point for everyone, if they don't know, is to sort of work out how much they are losing money because of defects. So print quality control is essential for those three very reasons. It saves time. Time is money, and money is what we need to make for our organisation, and we want to dispose of less material, especially nowadays with everyone being so environmentally conscious. Everyone's sort of going green and very conscious of how much material they actually throw out. So all these things can be improved if you have a good print quality management program in place and some SOPs and standardisation. So this is a test that I often do. I don't know if anyone else on the call does it, but I tend to look at all the packaging when I go into a supermarket. I just don't go in and buy what I go in to buy. But I know for a fact that this is quite a true statement, that if you see some tomato soup on the shelf, there might be 5 cans in a row. If one of those cans is faded, or it's out of registration, or it's ripped, the paper might be ripped, or the film might be ripped, I guarantee you that you wouldn't buy that. And if the whole range on the shelf is like that, then, as it says there, that looks like an old... Excuse me, can someone please mute? It's sort of... It becomes an untrusted company, looks like a cheap product. It looks old if it's faded, right? If it's washed out and the ink is not to its true density, it just wouldn't sell. They might as well take it off the shelf. So, do you know how to maximise savings with print quality management by process control and standardisation? Because we want to see that arrow going up, don't we? Quality control is more and more of great importance in the printing industry nowadays because of there's increased competition. A lot of companies are ISO certified. Automation is taking over, and quality standards are higher. But I think another impact why it's important to have a program in place is because print runs are becoming smaller. So you don't have, instead of being 50,000 sheets, it might be 5,000 sheets. So you don't have that time for the print to settle down, the machine to settle and to become stable. It needs to be done as quick as possible. So you need all your parameters and all your inputs and outputs to be at the optimum process, because otherwise you're just going to waste sheets, because your run's only 5,000, so it's got to be at the right standard from start to finish. So when we evaluate print, we do it in two ways. First, we do it visually, of course. So if you're on a press approval, part of the way to manage it is to make sure you have all the instructions from the client on hand. You need to have a proof, and you need to have instructions of what are the priority points for their colour choices, like the graphics or the brand colours. So with visual, you just check, it's a quick response, and you'll just check content, make sure the barcode is reading the correct numbers, all those standard things that we would do. But then we need to validate the colour with an instrument, because we all see colour differently, correct? So you need to make sure you measure the colour either with a densitometer or a spectrometer, and that can validate that the colour is correct. This is all part of the print quality management programs, print quality management system, and it achieves consistency, because if we measure with numbers, then we got something to clarify it with, and we can always use that number again when the product comes up for reprint. So print quality attributes, print density, grey balance, dot gain is a big one, print contrast, print gloss, colour trapping and colour matching. And you can see there the print quality contributors. I think we're all familiar with them. The press settings have to be at the correct settings, obviously. Flexload plates can be troublesome. They're a lot better nowadays, but previously can be very, very troublesome. Cylinder engraving needs to be done correctly. Analog rollers need to be of the correct choice. Doctor blade settings, quality. So I'm just admitting someone into the room. Film and paper chemistry, the pH and humidity and temperature. Ideally, it'd be great if every printing factory had humidity controlled print floors, but I'm sure that's not the case. And that really does contribute a lot to unstable printing environment, is humid, cold, the change in temperature, the fluctuation in temperature, and the ambience of the print hall itself. So density, the colour capacity of printed colour to absorb light and therefore not reflect it. So what we see is the reflected light. So the pigments absorb the colour, and then we see what's reflected. So there's a simple equation you can do to work out density, but we won't go into that. That again is, we're trying to get through these slides because we're a bit late starting. So these can be taken up again offline. I'm sure we can share. I'm sure we're sharing the whole presentation to all the people on the call. So you can review it, and any questions you can come back to us via email if there's not enough time today. So in the press room, of course, it says here, we measure density to validate the colour. It shows us the amount of ink which is on the substrate, whether it has to be increased or decreased. We have a tolerance level. I'd like to think that this around here, the +5 to 3, I think the industry standard is in this area. When you go to see a client and you put something in front of them, you say to the client, this is what you can expect to get, but there'll be a +5, -5 deviation, which is not really reflected to the human eye. So We don't want to go to the 7 and showcase one. Well, that'd be fantastic, but I think most printers would be happy to be sitting in this area here of +5, -5, or even better, +3, -3. So there's another simple equation for the reflection density. Is the function of the percentage of light reflected. The table to the right shows a relationship between the of percent reflectance to density. So if 100% is reflected, then there's nothing there. There's no color at all. And as we move down to 10%, 1%, this is the range we're sitting in again. As you can see here, this is roughly what your density value should be. I mean, some printers work to their own set of values, and some clients have their own set of values. I was at a printing factory in Malaysia doing a press approval for Starbucks, and I was sort of working my way towards these values, but then the printer said they'd done the same package previously, and Starbucks had actually signed off on a copy, and the density values are actually higher than that. So I had to sort of follow the density values that this printer had signed off for the Starbucks packaging. So this is this is the industry guide, but some printers do actually set their own standards for certain types of packaging or certain types of clients. So there's the correlation. I mean, I think it's quite common to understand that anything that goes thicker is generally going to go darker. So that this simple graph shows the correlation between putting more ink on the substrate and the fact that will make it darker, and that will increase the density, of course, because more light is getting bounced back. So to measure density, we have these color bars to monitor. Like, I'm sure everyone's seen them. I got an example here of the company I'm working in at the moment. So it's just your color bars there. So they get their densitometer, or they've got an X-Rite spectrometer, and they'll measure their values, and they'll input into the machine to make sure it can marry up with what should be the client's approved sheet. So as you can see here, 90% of the light is getting reflected. So there's not a lot absorbing the light. So it's got a lower density of 0.05. But as you move down, you can see the ink film thicker and thicker, and it's absorbing more, and that's the range we want to be in around here. I'm sure everyone's seen these on jobs. Everyone's used these, correct? Oh, everyone's muted, sorry. Sorry about that. So viscosity plays a big part in density as well, and the visual appearance of what we're printing, especially I guess in gravure, where it's a lot, the viscosity is a lot lower. But also in offset, I suppose, when it's a cold day and the ink might be stiff, you might pull it out of the ink tin and it's just a big blob of ink duct. You've got to put reducer in, or if it's a long run, sometimes the ink duct might be a little bit low, so you top it up, but all of a sudden the ink will sit back because it's not at the same viscosity as what was already in the ink fount or in the ink duct, and then therefore it will go a bit lighter because the ink's holding back. But after the ink becomes a bit looser and it warms up, then you will end up going back to your normal your standard running sheet, but it will create some fluctuation if it's a long print run. So it's best to minimize that if it's possible. With a gravure, it can be a bit easier because you can actually get your Zahn cup and make the ink you're going to put into your drum into the pump, that you can make the same viscosity prior to doing that. So you might get a little bit of fluctuation, but with offset, if it's a long run, sometimes you can get quite a bit. But this just illustrates what viscosity can do to the actual appearance of the print. So there's a light appearance. This is the standard, so this is the target. But the ink viscosity went a bit high, so it sort of filled in a bit more, and that went a bit lower, so it goes a bit lighter. But this is of course what our target should be. Reviewers are a lot more stable than offset, I believe. Dot gain is the difference between the apparent dot area. Dot gain is inherent in all print processes, and it's a major contributor to, I suppose, getting some press approvals rejected by clients because they don't understand it. That's fine. They shouldn't understand it because they're sort of, they're just marketing people, I guess, that don't really deal with this. But I think that one way around this is by doing fingerprints. I think a fingerprint is imperative to managing dot gain. So does anyone do, no, I can't ask you, I'll mute again, but I think that, yeah, dot gain is something that should be reflected, that should be compensated for prior to going to print. So it's when a dot gets bigger. It gets bigger for a various amount of reasons. It can be pressure, it can be consumables, it can be on offset, it can be a blanket that's loose, or some, rollers that not set properly. So yeah, so yeah, dot gain is one of the big contributors of that needs to be managed. I think it's one of the biggest areas of print quality management. So why we measure dot gain? In the press, we're measuring dot gain at 25%, 50%, and 70%. It shows how our halftones and all our highlight areas are running, I guess. So that's why we need to understand how our press is working, how it's running, and where we're getting our dot gain, and how to manage it. But we can measure it with the densitometer as we're running, but we can't really do a lot about it unless we stop and clean or do a check. It could be a gripper bar that's tight and that's slurring a little bit. But yeah, we need to measure it and need to be on top of it. Otherwise, your halftone images, they won't appear what the design is. That is a simple little comment there. So excessive magenta dot gain will cause flesh tones to go red. So, and it might, the client doesn't, if it's a nice baby on a package, they don't want the face to be going all red. So we need to be conscious of dot gain, and we need to manage it. We need to understand why it's happening. We can offer, tutorials on that with fingerprinting and characterization, but we can discuss, Mr. Ashfaq can discuss that with everyone at another time if they wish to have that tutorial. There's some typical dot gains in there, but I mean, dot gain, you can have a brand new Heidelberg Speedmaster in your factory, and 6 months later put another brand new Heidelberg Speedmaster in your factory, exact same model, but they will still print subtly different and have a different dot gain. So that's why characterization and understanding what's going on behind the guards and inside is very important. This is just a simple illustration of sort of how dot gain occurs. So that's from your design file, is your film's at 40, you lose a bit when you go to plate, then print, obviously you're getting some, and everyone, there's optical dot gain in everything we look at. So you've started with 40 and you've got 54, so you've got a dot gain of 14. So ideally on the file, you probably want, 36, something like that, or no, 30. You want a dot of 30 so you manage it properly. So that's basically what it is. It's just, there's the correct dot on the left here, and when it's enlarged, it's on the right. So like I said, there's various things that contribute to it, and that's you need to isolate what that is. Is it your machine? Is it your pressure? Is it the ink you're using? Is it your plates? Is it your maintenance program? It all needs to be isolated So yeah, it's very important that we understand where dot gain comes from. Here's some like plus minus percentages. It would be great to be in here, but I think, you know, most processors would hover around down here somewhere, if not lower, if they don't do their due diligence. So this is some examples of too much pressure. This is talking about offset more than anything. Too much pressure between the impression cylinder and the blanket. What can happen? It can increase slurring, and the blanket might be loose even. So this goes back to maintenance and checking everything, and you can get some doubling. In gravure, if your blade angle is not correct, you'll get slurring as well. So this comes back to training, I guess, as well. Training is important. All the pressmen need to understand exactly how they set their machine up. So this can mitigate all these kinds of defects, because again, defects is waste, waste is money. Dot gain, here's some examples again. I'm going to go, sorry, but I'll go quite quickly because there's still quite a way to go, and we're sort of not running on track of time. Higher printing pressure is obviously, it will lead to greater dot gain. It's obvious that if a blanket is pressing against the substrate and jamming it in between the cylinder, then it's going to squash the dot on the blanket, as opposed to having the kiss effect, where it should just come around and just sort of touch the substrate lightly, then increase it a little bit more, and then that can decrease your dot gain and in offset anyway. No, that can work in gravure too, with your impression sleeve down onto your cylinder. Ink film, thick ink film can also create a larger dot, obviously. And printing plate deformation. Viscosity also, we talked about it before. The example before where the viscosity was high, so obviously the dot grew and it got darker. The viscosity was low on the example on the right, so obviously it was lighter. So viscosity is very important, and you can see the difference in although they're not so clear, the pictures, but you can still get some kind of understanding of if you look at 16 seconds to 28, that's quite a significant difference. If you got that in a halftone image on a face or something like that, then that's automatic rejection. Ink trapping, there's two types of ink trapping. There's the there's overprint trapping, and there's also register trapping. We'll only discuss the overprint trapping today. The register is all part of how you prepare a print ready file based on your printing specifications. So I'll just go quickly. I think if it's 100, like for trapping purposes for the cyan and the magenta, if it's both at 100, it wouldn't work. So ideally the cyan's at 100, and then we trap it with an 80% magenta over the top. And sequencing is very important when it comes to trapping. I mean, our CMY K sequence is CMY, and sometimes we run K on the back or up the front, but generally it's CMY. So if you swap the magenta and the yellow around, you can have a different effect. So it's very important to make sure you understand what you're trying to achieve if you change your sequencing from CMY, and you just file accordingly. Here's an equation. Again, we won't go into this. It's sort of a topic for another an extended version of this kind of discussion. But again, you'll get this presentation, so you can go over it and come back to us with any questions you may have. Here's the ideal percentage. Is red for the red. 70% green and 75% for the blue. This is the equation. This is the summary of the equation up the top here. This is how you can adjust or determine your trapping value. But densitometers and spectrometers, you can also take a reading and get your trapping value. There's on the color bars at the back. They're actually not on this one, but there's an example in the next slide or two. On the color bars on the back, they'll have the very line up here of trappings. This is an example of the three examples of how just cyan and magenta can look different depending on the way it's trapped, and if it's on dry. This is wet on dry. This is wet on wet with the magenta down first. And this is wet on wet with the cyan down first. This is probably, well, this is the one you would run to. This is a CMYK one. And this is the most commonly used sequencing. So there's your 100% cyan and your, I guess that's supposed to be 80% magenta on the top. Hang on 1 second. So there's those trapping bars I was talking about before. If you can measure these with your densitometer or your spectrometer, and that'll give you your percentage. So these usually are on the back of all sheets. I'm not sure. I'll have to ask the company tomorrow why they're not on that one. And there's your solids black CMYK. This is so you can obviously use your densitometer to track your run sheet. So if you pull out every 300, 400, 500, I'd like to think everyone pulls a sheet out at least every 500. Lots of things can go wrong in 500 sheets on a printing press, or offset anyway. Question about the old looking package. That would be the one on the right that's light. The one in the middle might be the good one. So you need to make sure it's consistent all the way across. I think lots of printing presses now have automated spectrometers inside them, but I think it's still good for the human eye and the person on the end of the press to take readings just to clarify what the machine is doing. These are just half-tone patches that some of the things we discuss can vary from print factory to print factory. It depends on their print quality management program, right? This is just an overview of ideally what you should have operating within your organisation to reduce all those things we discussed at the start of the presentation. These Fogra seem to be the most popular nowadays. And these are this is to monitor your slurring and doubling. This is from your fine lines, and there's your tonal wedges, all of that's there. Because some of it might be very fine, maybe not visible to the naked eye properly, but still my internet was unstable, so I'm hoping everyone can still see it. Can everyone, is it still like? So measure half-tone dots using a densitometer. Measure the density of the darkest area. I won't read all this. I think you can read it once you get the presentation yourself. Subtract the lightest area from the resultant image, but you also need to inspect with a magnifying glass. When you're on press or even in the office checking samples, you should always use an eyeglass to check your dots to make sure everything's fine, make sure they're aligned, make sure there's no pinholing, which sometimes pinholing can, if it's printed on white, it can let more white show through, and all of a sudden your colour's looking light and washed out. You need to make sure your dots are nice and sharp. And this is back to the fingerprint all over again. It's the best way to make sure that your machine is exactly what you're printing, exactly what you want it to. Then you can also manage your input to get the output you want. Spectrodensitometer working. Well, we've talked about that before. Everyone sees colour differently. Doesn't matter what light you look in. It's still, if you look under the the normal room lighting. It's different to a light box or even natural sunlight, which is D50 light. So it's my recommendation that if you ever do a press approval and you haven't got a light box in your factory, at least try and find a window and look at it near a window. Not many press approvals I go on, I'm in the boardroom and I'm looking under a downlight, but to me that's unacceptable because it's not a true indication. Even if some you can go on press, but nowadays with COVID, it's not very often you can get on the factory floor at the moment. So this is just an example of it's trying to illustrate. This is an example to illustrate the difference of me or you observing colour and making a judgment, and then the spectrometer making an accurate judgment through numbers. And it's something that can be repeatable. If I look at a sample here in this room now, I might look at the same sample at my office tomorrow and it can be different. But if I have a spectrometer here now, I can measure it and I can go to the office tomorrow and measure it. And it might look different to me, but the numbers will tell me it's not. And light, like it says there in that pink down the bottom, without light, there is no colour, and the type of light plays a very big role. It really does play a big role in how we perceive colour. I was recently working on site as a technical support for Kaufland here in Melbourne, and we were checking proofs against colour standards just in the normal office. And so I asked my operations director that we definitely need a light box. So we purchased a light box and made it mandatory that any kind of colour evaluation was done in the D50 light box. So this is basically the colour spectrum for the LAB model, which is the spectro. So L is light, and then you've got your A and B axis. Yellow, B is yellow and blue, green and red. So this is saying, this little example is saying that the colour that is on these coordinates is somewhere in here somewhere. But you can see here the difference, like the LAB reference for the target and the actual. So they're a long way out. We want to, ideally you'd want to run to an LAB or delta E of between 1.5 maximum. I'd like to think 1 is as high as you could go, but most clients, like I've worked with major global clients, most of them will tolerate 2, some even 2.5. I think Starbucks was 2.5 for some of theirs. Yeah, but we want to keep it as low as possible. So your target is 0 really, but it's quite difficult to achieve, I think. So the difference between two colours expressed in delta E, that's delta error in the LAB colour space. 1 is the smallest colour difference that a human eye can see, and that's a trained eye. Like a lot of clients don't really understand this part of it, and you need to educate the clients. I think it's important they are educated, and they can understand a lot more. But to be honest, that's part of print quality management too. The clients understanding, because it makes it all easier. It means there's less waste because they understand and accept the samples you put in front, if you can educate them a bit. So yeah, look, you can see the delta E deviation that this previous example came to, like that's 8.6, and you can see here that the delta E between 0 and 1 is not normally visible. Between 1 and 2 is only visible to people within the industry. That's why I'd recommend to aim for 1 or 0, but at maximum of 1.5. But of course, if the client's happy with 2, then so be it. You know, but still, from a performance level, you want to achieve the best you can, right? Our good old friend registration. I think everyone must know what registration or misregistration. Sorry? Oh, I'll keep going. Yeah, misregistration. I mean, we all know what that is, and that can happen for various reasons. It's where this is your registration, your eye, where you want all the 4 colours on to be aligned. This is misregistered, right? But you want them to be exactly on point to make sure it's in registration. And on the actual printed sheet, of course, you've got your little target area there, so that's what the printers go for. Most reviewer presses, it's done by an electronic eye, but there's many things that can affect registrations: structural vibrations, a loose printing blanket, slack edge on the stock, it could be wavy stock, doctor blade chattering, it may cover up the sensor, the block that the sensor reads, and all of a sudden your registration will go out. Tension, of course, printing pressure variations, measuring errors in the camera, that'll be for good viewer, and flexo, of course. So registration is monitored on the bigger presses by a camera system, but still it's something that needs to be monitored by the operator as well, to make sure that everything is in place and the cylinders are wiping clean, or your sensors are working properly. Otherwise you will have misregistration, and again, it'll be on the shelf and it will get rejected. And it costs money. Gloss is defined as the intensity of reflected light. I'll let you read that because we really are pushing here at the time. It's a very important parameter for those paper subject and final print. It's the angle, like if you look at we're talking about if you look at a paper book, then sometimes you've got to hold it down to an angle to see the glossy side of an ink. And this is what we're talking about here, is the angle. And these angles here are for your gloss meter. I'm not sure where you buy a gloss meter in your parts of the world, but if you have a gloss meter, you can actually measure the gloss and understand it a lot more. So we'll move on from that one and keep going. Colour matching. Well, we've talked a lot about colour matching, but some of these, and believe me, some of these can happen. It's when we have our target and we have the actual printed sheet and it's not marrying up properly. So there can be various reasons for that. There can be, the wrong ink may even be put into the press, and this is pretty common if you're mixing ink in-house. Not with a proper ink mixer, I guess, but if your printer's assistant is mixing himself, this is why I recommend that if you have a big print run, I would get the LAB references and I'd give it to an ink manufacturer and get an ink drawdown and make sure that you have your LAB referencing. That way, then you know your Pantone colour is correct and it will be stable throughout the whole print run. And if the print run comes up again, then you've already got your mix, you've got your recipe. So you can either make it yourself or you can get the ink manufacturer to do it again. But some of these problems here can be eliminated by doing those kinds of things. We're actually doing that in the company I'm in now. They've got a guy in to help collect all the brand colours, all the base colours, and we're going to get them properly mixed and start using drawdowns as our colour targets. Again, they're colour viewed under incorrect lighting. That's a big one. Yeah, so we'll move on again. Inks are translucent. Light penetrates into the ink. Ink film thickness. This is the thickness of when it's actually on the substrate. A thick layer of ink absorbs more light and it makes more darker. We've discussed that before, and that's why if your density is up, then obviously the ink film thickness is darker. But when all the chemicals evaporate and it's just the pigment and the resin sitting on the substrate itself, it actually shrinks in size. But still, it'll still be darker. If it's printed darker, it'll still remain darker. And there's some parameters that you should be working to with ISO. So here's some things that can affect the lay of ink onto the substrate, I guess. Yeah, incomplete contact between the substrate and the ink film, and this is what can cause it, and then problems also. I can let you read these, guys. You will receive the presentation. Surface energy, ink transfer is overall small, especially in halftone areas. Here's the printing pressure and print speed, and the roughness of the surface play a great role in the ink transfer. So we'll move on to the next one. This is all about surface tension. Surfactants help them let the molecules rise to the top, so that's when the ink dries. We need surface tension, but we also need adhesion. So we have the surface tension. Sorry. Come on, mute, please. So when they don't have sufficient time, so the voltage of surface tension is imbalanced. Someone mute. To help with surface tension, you can add surfactants into the ink, or you can treat the film or something with a corona treater, which can help the ink adhere to the substrate. You can check the adhesion with a dyeing test that will let you know if you have good adhesion.
हेलो
Hello?
हेलो आवाज आ रही है हेलो असद आवाज आ रही है
Please
हेलो
Yes.
please mute. Thank viscosity, temperature plays a big role in viscosity and print density. If a decrease in temperature, the viscosity will fluctuate. If there's an increase, the ink density will increase. So temperature control is extremely important. And so again is the ambient temperature of the printing factory itself. You can see there some of the results of temperature rising and falling. Dot structure. Hot inks that deform dot structure and have that donut effect. This is what I was talking about before. If you have a dot that's not properly formed, then if it's on a white substrate or white backing, then more of the whiteness will come through, and it will make sort of make the halftone images look too bright, or the background colours won't look as consistent as they should. I had this happen to me when I was on a press approval as well. The white cylinder wasn't engraved properly, and we were having major issues. So we had to abort the whole thing. So yeah, the donut effect and these kinds of things can play a big role in the finished result. Haze versus temperature. Again, we've all had hazing. I guarantee that this is some of the effects. Doctor blade pressure may reduce haze if you put a little bit more on. That's in gravure, obviously, but yeah, hazing, when we print money, the Australian money is plastic, the polymer money, that's a $50 note. And quite often with the clear window, if you can see that we used to get a lot of hazing in there. I used to print the money here in Melbourne, and that was a very common problem, what they're talking about here, or what the slide illustrates here. And so yeah, that's something that really needs to be monitored. Printing pressure, we talked about this a little bit before. It can assist in print, but then again, it can have an adverse effect as well. That's where it's a balance between what the press is set up to be, if it's maintained properly, if the printer knows exactly how to operate his press properly. But these are some of the things that can affect the final quality of the prints through pressure, like the pressure between the rollers. The rollers need to be maintained. They need to be set correctly, especially the dampening rollers. If you don't have your dampening rollers and your ink rollers set properly, not only will it create issues with the pressure and all that kind of stuff as it on the plate, but you'll end up with bad emulsification. If your dampener roller is not set properly, if your nip is not correct, then you might be bringing so much ink up, all of a sudden gets in the roller train, and you'll have spitting all over it and all over your sheet, and you'll have to do a full wash up. So this comes back to training and maintenance. This is another area that we could offer more tutorials on, because I think it's extremely important, and it's a big part of print quality management is training and maintenance. There's your between blanket and impression cylinder. We were talking about that before. So, and this is where it can help. If you've got like a sketchbook, you know, when you buy a sketchbook and you want to draw a picture and the substrate's sort of porous and rough, if you want to put a nice smooth vignette or a nice solid on it, and you run to your normal pressures, it probably look a bit like this, and you'll see all the substrate would be showing through here. But if you add more pressure, then it closes in a bit more. But if you squeeze it that little bit more, then it might cover up all those impurities and it would look like a nice smooth layer of ink. So adding pressure, it can actually assist. So you've got to find that balance of where you're doing damage to the print or you're actually assisting it. And there's the magnified images and what they actually illustrate there. So viscosity, I think, is how to explain that is how runny the ink is in layman's terms, I guess. But there's pros and cons. I mean, if it's too high, it dries too slowly, poor rub resistance, and inferior ink appearance. But if it's too low, then obviously you get washed out print like we saw before in the previous examples. You get splashing and foaming. So ink viscosity, especially in gravure, is in all print process, but gravure is, it needs to be probably really monitored. And even if you're using an automatic viscosity unit on your gravure press, it always pays to put the Zahn cup in and do a test to make sure it's working correctly, because many times that may indicate it is, but it's not, and you don't know. Your reel is winding up and you might be winding up a spoilt job. So if you can just read this, some printers try and adopt a way of making it work better, but it's not always the case. That it's not always the correct way to go. So this is the same picture illustrating a dark appearance where it's 30 seconds, 25. So 25 is what we want, but then it crept up to 30 and it's too dark, and then it goes down again and it's too light. So yeah, viscosity really needs to be managed. Sometimes I think like I said before, with offset, it's not as easy as it possibly could be, because especially on long runs, but runs are getting shorter, but if it's a long run, then sometimes you can have that holding back in the duct. pH, we all know water hardness is different around the world. Some places I've lived, it's really good, and some places I've lived, it's not so good. So we have to have the pH adjusted correctly. It can wear your plates out very quickly if it's not, and there's some other issues you get with incorrect pH. I suggest checking your pH almost every morning. It's not hard to have a quick check. If not every morning, at least every time you change over your fountain solution, you should be double checking, because it's really good in trouble if it's not correct. Even with analog control, it can get plugged in. Someone's off mute again. Can you please mute? I think that's pretty self-explanatory for the pictures that are illustrated there. And this is just a viscosity record, which, yeah, you could have on press side. You could, like I said, you know, the time you've checked your pH and the viscosity of the ink. I think, especially the pH viscosity as well, but pH should be monitored very closely, because it's sort of a silent. It gives problems silently. I think pH. I think it's the last thing people check when they're having trouble. You know, they check the ink, they check everything else, and I think it's the last thing that people really sometimes get to. Not everyone, I guess, but yeah, sometimes it's the last thing people check, and it quite often can be the contributor to spoilt work. So that's it.